11.1 Relative motion in one dimension. How fast an object is going depends entirely on your point of view. For example, right now as you're watching this video, you might think that you are just sitting still, moving at 0 meters per second, studying physics. But that's only from one point of view, from the point of view of the Earth below you. If you look at your motion from other points of view, for example, from the point of view of the sun, the Earth is rotating around the sun and you're on the Earth. From the point of view of the sun, you are moving at 100,000 kilometers per hour with the Earth. As the Earth orbits. From the point of view of the center of the galaxy, as our solar system whips around the outside of the galaxy in orbit, from the point of view of the center of the galaxy, the solar system, which you are part of, is moving 792,000 kilometers per hour. Which is really fast. So you see, even though from the point of view of the Earth, you are moving at 0 kilometers an hour, your actual motion depends on your point of view. It's all relative. In physics, we use the word relative to describe these different points of view. The term relative to in physics means from the point of view of. So we would say that you are traveling 100 kilometers per hour relative to the sun. The relative to here means from the point of view of. You are also moving 792,000 kilometers per hour relative to the center of the galaxy. This means from the point of view of the center of the galaxy. To find out how fast an object is moving relative to another, you just need to subtract their velocities. The term velocity is very important. Remember, velocity is a vector, so when you're subtracting vectors, you do need to take direction into account. So for example, if you have two objects, let's call them object A and object B. We would say the velocity of object A relative to object B. And the notation we use is VA rel B, which means the velocity of A relative to B. Remember, relative just means from the point of view of. And this is VA minus VB. The velocity B relative to A, VB rel A, is VB minus VA. Here's an example to show how these calculations are done. Consider three cars. Car A is traveling west at 10 meters per second. Car B is also traveling west but slower at 6 meters per second. Car C is traveling east in the opposite direction at 20 meters per second. First, we'll look at the velocity of car A relative to car B. This is VA rel B, or the velocity of A from the point of view of the driver sitting and watching in B. VA minus VB is 10 meters per second west minus 6 meters per second, also west. Convert these wests into negative signs first, so it becomes minus 10 minus minus 6, which is minus 4 meters per second, or 4 meters per second to the west. So car B sees A moving away at 4 meters per second to the west. The velocity of B relative to A, so the velocity of B from the point of view of the driver in A, is VB minus VA, which is 6 meters per second west, minus 10 meters per second, also to the west. Change the wests into negatives, becomes negative 6 minus negative 10, which is positive 4 meters per second. As A looks out its window to the back, B seems to be getting away from it towards the east at 4 meters per second. The velocity of A relative to C is the velocity of car A from the point of view of the driver in car C. VA minus VC is 10 meters per second to the west minus 20 meters per second to the east. Convert the west into a negative, so it's negative 10 minus positive 20 is negative 30 meters per second, which is 30 meters per second to the west. So car C sees car A moving away 30 meters per second to the west.